Now that we've learned a little bit of background for game theory, in this video, we're going to do two things. First, I'm just going to show you a little bit about how to read a payoff matrix for a game and how to understand or interpret game theory so that you can use it. After we finish that bit, I'm going to ask you to pause, and there is a file under files where you do some practice problems with game theory problems, and this is important for you to do on your own, so I'd like you to do that. After which I want you to go ahead and read the articles that are assigned for this class and then watch the rest of this video. Thank you. So let us start by showing you how to read a payoff matrix. So remember that for game theory, I need puppy. And depending on how I set that up, the payoff, the setup of the game and its results will be different. So I'm going to start with some assumptions. This is a perfect information game, which means that both players are fully aware of the payoff matrix. It's like chess. Everybody knows not only their own payoff, they know what the other person's actions and payoffs can be. Two, it's a non-cooperative game in that there is no transfer of resources, there is no pooling of items across players, and each player is only focused on their own needs and their own benefits, and they are not focusing on the other person. So we're going to assume this for both folks, and in fact this set of assumptions that everybody is maximizing their own utility was also part of Becker. So we're going to stick with that. We're going to stick with perfect information. And we're going to start with an example that's going to look pretty similar to Becker. All right? So the way we'll set it up is that there are two participants. Person 1, who I'm going to call male just accidentally, and person 2, who I'm going to call F for female, which just as it happens. They have two possible actions. You can choose X, or you can choose Y. Let us say that choosing X would mean following traditional gender roles, and choosing Y would be to have different kind of arrangement in your partner, between your partner and you in terms of adjusting, all right? That could be one way to put it. It could be a small thing because it's a single discrete game, like shall we go and eat Chinese food or shall we go to a movie? Yeah, okay? The one item, even though the information is transparent to everyone, is that my reward will not only depend on my action, it will depend on the action of the other person as well. So here is the way it would work. I'm going to set up a payoff matrix as follows. This is person F. They can choose X or they can choose Y. And this is person M, and they can choose X or they can choose Y, which gives me 4 options. So now that we have 2 people choosing between 2 options, X or Y, and some rules of the game in terms of how we apply this. No cooperation, no collectivization of resources, perfect information, all of that. We're now going to learn how to read the payoff matrix. So we have 2 people. Up here is person M. Down here is person F. And then 2 actions, X and Y, X and Y. So up here, this box tells me that person M chose X and person Y also chose X. Both chose XX. In this box, M chose Y, so no longer at X but at Y, but F is still choosing X. So the choice set becomes YX. Over here, person M is choosing X, but person F is choosing Y. So M chooses X, F chooses Y. Over here, both choose Y. And then, if you look at the problem set, it gives you a payoff matrix where depending on what the other person chooses, you can figure out what each person's payoff is. So I want you to practice those problems, read the Amartya Sen article, and then look at the rest of this set of videos.